This is your lesson on rational exponents. It follows the textbook 5-7. Let's get started. All right, we start off not too terrible where we're just reconverting the form. I have forms in exponents and I just need to rewrite them in terms of a radical. When I see a to the 1/4, the expression really means just take the fourth root of a to the first. Notice that the denominator of your exponent becomes the index of your radical. So x to the 1/5 power would really just be the fifth root of x to the first power. Let me quickly just throw one in here. If I were dealing with x to the 2/5 power, that would really just be the fifth root of x squared. Okay? Properties of radicals and exponents actually will really help you with when it comes to simplifying expressions. So the third root of y, that can be rewritten as y to the 1/3 power because the exponent inside the radical is really just a 1. The eighth root of c, that's really going to be c to the 1/8 power because once again that exponent underneath that radical is just 1. So let's actually start using these properties here. Recall that whenever you see a negative exponent, it means it's just going to flip its location. So I'm really dealing with 1/16 to the 1/4 power. Okay? All right, so let's think about how 16 can actually be rewritten. Let's give it a base that we all know and love. How about 2? 2 to what power is 16? Well, how about 2 to the 4th power? And that's still being raised to the 1/4 power. And when you raise a power to a power, you multiply. Well, 4 times 1/4, that's just going to be 1. That's why we get 1/2. Let's try this with a bigger one. A little bit more scary here. This 243 to the 3/5 power. Can we rewrite 243 with a smaller base? Let's try 3. 3 to what power is 243? Well, 3 to the 5th power is 243, and we're still being raised to the 3/5. Now, once again, when you raise a power to a power, we're going to multiply. And 5 times 3/5, that's just going to leave us with 3. So we're really just dealing with 3 to the 3rd power, which is just 27. In this real-world problem, we're once again just given a formula and asked to plug in values. So please get your calculator out so that you're practicing typing things in. So we're asked to solve for the maximum amount that this guy can lift, the mass, okay? And we have 512, and we're going to subtract this large number. And B represents a mass kilograms in 2 lifts, and we are given a B of 72, and it's being raised to the negative 8/5 power. Like I said, please make sure you're typing this actually into your calculator, okay? When you type this actually into your calculator, you should get approximately 356. And in the context of this real-world problem, our units is in kilograms. And this is the maximum amount that this 2000 Olympic champion can lift, okay? So, comparing this to the predicted formula, where he actually lifted 367, so he actually lifted more than what the formula predicted, okay? So now let's keep on going. Let's continue to use our properties of exponents with rational exponents. So I have this expression x to the 1/5 times x to the 7/5. Well, when I am multiplying things with the same base, I'm actually going to add their exponents. So I really have x to the 1/5 plus 7/5. Well, x to the 1/5 plus 7/5. 1/5 plus 7/5 gets me 8/5. What about y to the negative 3/4? We all know that if we have a negative exponent, we need to change its location. But you're not allowed to have radicals in the bottom, and that's what really having a rational exponent will do to you. So you really in the bottom have the 4th root of y to the 3rd. It's not allowed. So let's rationalize our denominator, but let's continue to use rational exponents. Think about the goal in mind. We want to have y to the 4/4 because that'll just simplify to y. Whenever we're multiplying, we add exponents. So 3/4 plus what gets us 4/4? Well, the answer would be 1/4. So we're going to multiply both the top and the bottom by y to the 1/4, which will simplify to y to the 1/4 over this guy here, y to the 4/4, or just y. Please keep in mind you cannot have rational exponents in your denominator. Last example, let's keep continuing to use our rational exponents. We have the 8th root of 81 over the 6th root of 3. Notice that we have two different indices. Well, the only way to combine two different indices is actually if we have the same radicand, or in the case of rational exponents, the same base. So let's play around with this. The 8th root of 81, well, I don't need to rewrite it. We can rewrite it as 81 to the 1/8 power. Just like we can write the denominator as 3 to the 1/6 power. Let's see, can 81 be rewritten with a base of 3? 3 to the power of 4 is actually 81. So far, I have not touched the denominator. When I raise a power to a power, I multiply. 4 times 1/8, that's 4/8, which simplifies to 1/2. When I am dividing and I have the same base, these both have a base of 3, I'm actually going to subtract their exponents. So I have 3 to the 1/2 minus 1/6. 1/2 minus 1/6. Well, we need a common denominator in order to subtract fractions, so I can just rewrite 1/2 as 3/6. 3/6 minus 1/6 gets me 2/6, which that's equal to 1/3. So I'm really dealing with the problem of 3 to the 1/3, or you can just say the cube root of 3. Let's look at the next one. We have the 4th root of 9z squared. Doesn't look like there's a whole lot to do, but let's see what we can handle. The 4th root of, well, 9, that's really just 3 squared. Let's see if I break this up, what happens? I really have 3 to the 2/4 times z to the 2/4. 2/4, that just simplifies to 1/2. And a quantity raised to the 1/2 power, that just means a square root. So I'm really dealing with the square root all along. All right, now we're getting into a little bit uglier of expressions here. But once again, we can't have rational exponents in our denominator. Just like before, we're going to have to multiply by something, and in this scenario, we're going to multiply by the conjugate. So the conjugate here is m to the 1/2 minus 1. And what you're going to do to the bottom, you must also do to the top. Okay? Now on the bottom, it produces a difference of 2 squares, if you recall. So I'm just going to really quickly rewrite our difference of 2 squares. But on the top, we must FOIL out. Okay? Let's FOIL out right here. Let me write my numerator problem. M to the 1/2 times m to the 1/2. When I'm multiplying, I add their base, or I add their exponents. That's going to give me an m. Then we're going to have m to the 1/2 times -1, giving me a negative m to the 1/2. And we're going to have that again. And then lastly, we have -1 times -1, giving me +1. All right, so now the bottom part, power to a power, we multiply. 1/2 times 2 just gets me 1. So it's going to be m to the 1st minus 1 on the bottom, because 1 squared is just 1. Now on the top part, we have two things that are like terms. So we're going to end up with m minus 2, m to the 1/2 plus 1. And there you have it.